I welcome you to this online tutorial on formula stoichiometry and mole concepts. This session is suitable for students in senior 2, 3, and 4 in O level. So today we are going to we continue from where we stopped. We are going to specifically handle empirical and molecular formulae. And I will remind you that if at all you have any questions, feel free to contact me on these contacts, which you all have. And today is 10th of January. Next week is elections. And we are anticipating that the government is going to take off the internet. However, whatever the case may be, we are not deterred from doing what we are supposed to do. Therefore, today I'm going to be a bit fast and I'm going to upload many sessions. I'm going to upload many sessions since it is a race against time. So today we are going to look at the empirical formula. And before we look at empirical formula, I'm going to first give a real life example. Normally in life, let me give you something which you are going to imagine of. If I have two students, below, if I have Brian, and Christine, suppose that I have let me take an example of which amount. Suppose that I have 6,000. Suppose that I have 6,000. Suppose that I have 6,000 Ugandan shillings. Suppose that I have this amount of money, and I want to give 4,000. I want Brian to take 4,000. Recall that I have 6,000. Then I also want Christine to take 2,000. Yeah. So this is how I'm dividing my 6,000. I am giving Brian 4,000. Then I'm giving Christine 2,000. So I can determine the simplest ratio, because this is taking Brian is taking 4,000, Christine is taking 2,000. I can determine the simplest ratio in which this amount was shared. How will I determine the simplest ratio? I'll come and say, to determine the simplest ratio, I'll come and say, I'll divide by the smallest. I'll get this 4,000, which Brian took. Then I divide it by the smallest, which is 2,000. The smallest of the two amounts. Then 2, we have 4,000. We have 4,000 over 2,000. Then this to 2,000, I divide it throughout 2,000 over 2,000. Now you are all experts in algebra. You are all experts in algebra and mathematics. If I divide here 4,000 over 2,000, I get 2. Then 2,000 over 2,000, I get 1. So therefore, initially I had 6,000. Then Brian, in actual sense, I wanted Brian to take 4,000. Then in actual sense, I also wanted Christine to take 2,000. But the simplest ratio in which this amount was divided amongst these two students is 2-to-1. So Brian took a portion of 2, and then Christine took a portion of 1. Therefore, this is what we call the empirical ratio. This is the simplest ratio in which the amount was divided. So it is the empirical. If I'm to determine the empirical, what should I call it? The empirical formula that shows how the amount was divided. The empirical formula that shows how the amount was divided, I'll say Brian took 2, then Christine, sorry. Brian took 2, then Christine took 1. So this is the formula. But in actual sense, this is the amount which was shared. So this is the simplest ratio in which the amount was shared. Therefore, we have the following. So this is the empirical, but this was the actual sense. So in simple terms, we have the following. Let me take off this. Let me take off this. In simple terms, we have the following. By definition, we are going to say that empirical formula is the simplest formula. Take note, is the simplest formula that expresses the ratio in which different atoms present in a compound exist. It expresses the simplest ratio. Yeah, I think this information, you have it. It depends. If you are watching this video for the first time and you haven't covered these things at school, feel free to note this information down. But we have covered this at school with a certain group of students. So you need not write this again, but the items you write. As of now, for this session, you can just follow, because I believe you have these notes in your books. But if you don't have, still you will remain the same if you write them somewhere. You are not going to change. Yeah. Still your what? Your energy will not be consumed. All of it will not get exhausted. You remain the same. So empirical formula is the simplest formula that expresses the ratio in which different atoms present in a compound exist. While the molecular formula, so empirical formula, simplest ratio. While the molecular formula, here we look at the formula that shows the actual number of each atoms, the actual number. So considering my example, my real life situation which I have given you, look at the molecular formula as the actual amount, then empirical formula, the smallest ratio which I have obtained. Then, for example, I give an example here. We have this hydrocarbon. This hydrocarbon which you are seeing here, it is called ethene. Now it has 2 carbon atoms. Hope you are seeing them. It also has 4 hydrogen atoms. So in simple terms, we are going to say that it has 2 carbon atoms and 4 hydrogen atoms. And these atoms of carbon and hydrogen, they exist as follows. So the elements that are present in this compound are 2, that is carbon and hydrogen. So elements present, that is carbon and hydrogen. Then their number, the number of carbon atoms, they are existing in this ratio. For example, carbon atoms are 2 and hydrogen atoms are 4. Now this is the actual number. Now we want to determine the simplest ratio in which they are existing. Therefore, we divide by the smallest, as I have demonstrated in the real life situation, before. So we divide by the smallest, and the smallest is 2. So here we shall have 2 divided by 2 to 4 over 2. And what do we obtain? We obtain 1 to 2. Therefore, the empirical formula in this case is CH2. So you see that the molecular formula is something in its actual sense, but the empirical formula is something that has been reduced. Now we have these steps that are followed in calculating empirical formula. Now we saw these steps earlier on at school. As of now, I'm going to explain them again using an example, but as of now, you can just appreciate them. But I'm going to come back to them. So you identify and write down symbols of elements. That is the first rule. The second rule, write down the percentage composition. Then the third rule, you work out the number of moles. I'm going to come back to these steps. Then the fourth step, now let me explain this in detail. The fourth step, this is very important. The fourth step says that there is something here which I want to highlight. The simplest mole ratio, determine the simplest mole ratio by dividing the calculated moles with the smallest number of moles. We shall see this in detail, but there is something I want to comment on regarding this simplest mole ratio. Now, the simplest mole ratio must be handled with care. After determining it, you can now proceed with writing the empirical formula. But the simplest mole ratio has its what? A nemesizo. It has its technicalities. And below are the technicalities of the simplest mole ratio. Now, if you haven't covered empirical and molecular formula at school, as of now, you can just decide to watch, but with examples, you are going to see a clear picture of this thing very well with examples. These are theoretical terms which you may not interest yourself in, but they are important. Now, for that step of the simplest mole ratio, now here I'm saying that the simplest mole ratio obtained in step 3 should be handled. Note that I am highlighting this. Moreover, I am even writing it in black in capital letters, indicating that it is very important. Now, the simplest mole ratio obtained in step 3 should be handled with care, as discussed below. Now, how should it be handled with care? So, if you obtain simplest mole ratio, with the following figures, you have 1.1, 1.2, 2.7, 3.8, 2.9, and anything 0.1. If I say 1.1, now it is the same thing if I have 2.1. If you have 2.1 or 2.2, anything 0.1, yes, this first case represents anything 0.1, then this represents anything 0.2, anything 0.7, anything 0.8, anything 0.9. What do? So if you have anything, if these figures appear, they can be rounded off. Like if you have anything 0.1, maybe 1.1, you round off this and get 1. If you have 2.1, you round off this and get 2. Anything 0.1, 1.1. So this is what we have. 1.1 must be rounded off to 1. If it is 2.1, you round off it and obtain 2. If it is 3.1, you obtain 3. If it is 4.1, you obtain 4. Then anything 0.2, for example, here I have 1.2. If you round off it, you get 1. Then if you have 2.2, round it off, you get 2. If you have 3.2, if you round off, you get 3. Then anything 0.7, like here we have 2.7, you round it off and get 3. 3.8, anything 0.8, for example, 3.8, you round it off and obtain 4. Now, if you have 5.8, you round it off and obtain 6. 7.8, round it off and obtain 8. Now, 2.9, still you round it off and obtain 3. 1.9, round it off and obtain 2. So in these cases, you round off. However, I have said I'll explore these things furthermore in detail. If figures of the following form, if you have anything 0.33, 0.5, 0.66, 0.4, if you have, it shouldn't necessarily be 1 point. It shouldn't necessarily be 1 point or 2 point or 3. But if you have anything 0.33, 0.5, 0.26, 0.66, these points, 0.4. Now here, what do? You do not round off. You do not round off. Take note of that. Do not round off. What do? If you have 0.33, we say that the calculated ratio should be multiplied by 3. That is, if you have 0.33, then if you have 0.5, calculated ratio must be multiplied by 2. Then if you have 0.66, calculated ratio must be multiplied by 3. And 0.4, calculated ratio must be multiplied by 2. I think I'm going to come back to these things when I work out some examples. Then this note is also important. If you are given vapor density, I'll explain also this in detail. So as of now, As of now, I think allow me first to stop this session here. Yeah.